Hello everyone, so we're working through graphing today, so you'll need to follow along on the note sheet and then you'll need a piece of graph paper for your homework to work through this. So we're going to plot points on our plane, draw a graph by plotting points, and graphing nonlinear equations, then we're going to look at interpreting graphs at the end. So review, we should know this stuff here. So we have, this is called the Cartesian coordinate plane system. Okay, and we have our four quadrants first. We have our quadrant 1, we start in the upper right, and then we go counterclockwise from there. So quadrant 2 over here, quadrant 3 over here, and quadrant 4 over here. The other characteristics right here in the middle, that's called the origin. Okay, that's also coordinate 0, 0, if you remember something like that. We have the x-axis, which goes left and right. Okay, x is always left and right, we should remember that. And then we have the y-axis going up and down, okay? So we're going to review here how we graph coordinates in this system, okay? So remember, it's kind of, the x-axis is kind of like our number line. We go 1, 2, 3, 4, 5, and then we have 1, 2, 3, 4, 5 this way on our y-axis. So that's called the scale. So in our scale here, we went by ones. Okay, and it's positive to the right and it's negative to the left. So this would be my negative sector here, or negative part of the graph, and then this would be my negative y values on the graph. Okay, so say we wanted to graph the coordinate 3, 2. We want to graph 3, 2. Everything's positive, so that should be in quadrant 1, right? Both things are positive over here. So I'm going to go over 3 and then up 2. Okay, so that should be my point because it's x, comma, y. So I'm going right or left first, and then I'm going up or down second. So this is the point 3, 2. Let's say I wanted to graph the point negative 5, negative 1. Okay, so that means I'm going to go left 5 before, because I'm going to the negative x, and I'm going to go down 1 to the negative y. So going left 5, I'm here, down 1, right there. So that's my coordinate, negative 5, negative 1. That's what I'm looking for. Okay? So hopefully we remember how to graph. We have a few points that we need to label on the graph. So now we're kind of working backwards from what we just did. Okay? So we have A, B, C, D, E, F, and we're looking at the coordinate system on the left. So see if you can work through these quick and label each one of them. If you want to pause the video, that's fine. But we're going to work through these and write each coordinate off to the right where we have our letters. So if we're looking for A first, that's over here. We need to figure out where that is. So let's count left or right first and then up or down second. So we have 1, 2, 3, 4, 5, 6. So that's a negative 6. And then we're going up 1, 2. So negative 6 up 2. So that's the coordinate for A. Negative 6, comma 2. All right, hopefully you're kind of getting the hang of this. So for B, we're going left 1, so that's a negative 1. And we're going down 1, 2, 3. So it's negative 1, negative 3. I went left 1, down 3. Okay, so C, we're up here. So we're looking for this one. So I'm going to go right 1, 2. I'm going up 1, 2, 3, 4. So that would be a 2, 4. I went right 2, up 4. So hopefully we're getting the hang of this. So this one for D, next I'm going 1, 2, 3, 4, 5, 6, 7 right. Not going up and down at all. So this is the kind of an interesting one because it's on the axis. So that would be a 7, 0. Went right 7 and I did not go up and down at all. So E is very similar to that. I'm going left 1, 2, 3. So that's a negative 3, 0. And then F, going right 3, down 3. So that would be a 3, negative 3 for my coordinate. Okay? So hopefully you remember how to do those. You're just kind of looking left and right and up and down and just kind of picking, make sure you have the correct order. We want to go left, right first, up, down second. If we're going left, it's negative, right is positive, up, is positive for the y values, and down is negative for the y values, okay? So from the coordinates, we're going to graph points. We're going to graph lines, okay? So we're graphing this line right here, and we're going to do it two different ways. So we're going to do it with a table. That's what we're starting with, okay? So I just call this an XY chart. So you've seen this before, possibly in Algebra 1. So I'll have my X values here. That's what I'm plugging in. And then I'm going to get my function here in the middle. And then my Y values come back out just like that. All right, and we're going to try to do all of our XY charts just like this so we can see the work that we need to get the right coordinates. So we stick with generic values for the most part. All right, so these over here are what I call my generic values, -2 to +2. So what we're going to do is plug those into X in our function and see what we get back out for the Y. So, for example, for the first one, I'm plugging in a -2 for that X, okay? So right there is where I plugged in that value. That -2 goes right there. So I have 2 times -2 is -4, plus 3 is -1. Okay, so let's do it again for the -1. So 2 times -2 is, 2 times -1 is a -2, plus 3 is a 1. And then we do it with the 0, and it's just kind of a pattern here. So 2 times 0 is 0, plus 3, we get a 3. 2 times 1 is 2, plus 3, we get a 5. 2 times 2 plus 3, we get a 7. Okay, and then we have our coordinates here. So this is our X value, this is our Y value. So each one of these you can just kind of list it as a coordinate if you want to, but that's kind of the point of the table, all right? So we have our X all the way off the left and a Y all the way off the right, and the middle column is just our work. So let's plot these values and then connect the dots, because this is a linear function, this is a line. So -2, -1 is there, -1, -1, 1 is there, 0, 3 is here, 1, so 1, 5, we're here, and then 2, 7, we're here. And then we connect the dots and we draw our linear function. Okay? That's one way to do it, and that's the way that can kind of get you any graph that you want. You can always go to an XY chart, and you can pick whatever values you want for X, okay? We stuck to the generic values here, but you can do whatever you want. You can go up to 100 or down to a -100. That might be a little excessive, but you can do it, okay? Now I'll show you the other way that you might remember from geometry or previous algebra classes. So this is written in slope-intercept form. So slope-intercept form is y equals mx plus b, okay? And there are some characteristics of this that will help you graph it. So this right here is my slope. This right here is what's called my y-intercept. All right? This is where you start on the graph, and then this is what tells you where to go. All right? So we're looking at this graph over here, our 2x plus 3. I'm going to start at a +3. So I go up to 3 on my y-axis. All right? And then I have a slope of 2. So you always want to kind of think of slope as fractions, because it's rise over run. Okay? If you don't remember that, slope is rise over run. So you go up and down, then left and right. I always go right, okay? So I always go up and right or down and right. Up will be positive, down will be negative. Okay, so I'm going to go up 2, 1, 2, and over 1. Okay, same thing, I just continue that pattern. Up 2, over 1. Up 2, over 1. And then where I have my dots, I connect them. And that would be the equation of my line, which is exactly what we just did with the table, okay? Either one of these will be sufficient to graphing, okay? You can graph with slope-intercept. You can also graph with the table, okay? So make sure you follow the directions and do which one is specified for the equation. All right? So let's look at another one. So this one is a little bit interesting. because there isn't a whole lot of information here. All you got is y equals x. So if we're looking at slope-intercept form, well, you got to figure out what's in the place of m and what's in the place of b. Okay, well, we can rewrite this if we need to. For the first time here we will, but you're going to want to visualize this in the future. So in front of the x there's an implied 1. Okay, there's an implied 1. Then, since there's nothing on the back end, it's like plus 0. So my y-intercept is really a 0. Okay, so right there is my y-intercept, and then my slope is a 1. So I go up 1 over 1, up 1 over 1, up 1 over 1, and that's the graph. Okay? So I'll show you how this works when we make a table. So just like before, make our table of values, our XY chart. X goes here, and then this is really what we're plugging into. So this kind of looks a little bit different. So that's why I said there's not a lot here. You always put this right here in the middle column. Okay, whatever your mx plus b is, that's what goes there. And then you do your generic points. And you can see that there isn't really much to do here besides plot a one-to-one system here where you just got the same numbers. Okay, so we got -2, -2, -1, -1, 0, 0, 1, 1, 2, 2, which is exactly what we did here with our slope-intercept. Okay, so pay attention. There could be graphs where you got something like y equals 2x, y equals 3x. Those are all going to start at 0, and your slope is just given to you in front of the variable there. We could also have something like this where it's 1/3 x. Okay, this would be a flatter line, which is a slope of 1/3. Or you can have y equals 1/2 x, something like that. Okay, so it's just, remember, it's rise over run. So you go up 1, right 2 for this one. All right? So let's try this one. So this one has quite a bit more information to it compared to what we just did. Okay? There are a couple different ways you can do this one. My suggestion for these always would be to solve for y. And that will put you in y-intercept or slope-intercept form. Okay? You could do a table of values with this right away, but that takes a little bit too much work. So you're always looking to solve for y if you can. So what are our steps to solving for y here? Well, we got to get this term by itself. So let's move the 4x over. Okay, and then we got 2y is equal to -4x plus 8. You always put the x in front of the number. That x comes first because we want it in slope-intercept form. Okay, and then we've done stuff like this before, right? So let's move that 2 out of here. So that goes away. We have y equals, we got to simplify this stuff. So -4 over 2 is a -2x, and then 8 over 2 is a 4. So this is really the equation we're looking at. So you could, from here, make your XY chart, but I like the easier way, so let's do slope-intercept form. So that is the mx plus b way of graphing. So I start at my intercept, which is a 4, okay? So I'm starting at 4 on the y-axis, and my slope is the -2, which is really -2 over 1. So I want to go down 2 and right 1, okay? Down 2, right 1, down 2, right 1. And then you see my lines or my dots there. That's where I'm going to draw my line through, and I got my graph. And that is it. That's all we need to do, folks. Okay? So another thing that you can do to check this to make sure you did it right, so if you look at your slope, it's negative, okay? So that means the general trend of the graph is negative. You read a graph from left to right, okay? If I dropped a ball on the line up here or dropped it right here, okay, it's going to go down. The ball would roll right down that line, okay? That would be a negative slope. You're always looking for left to right. I'm going down, okay? So that's just another thing to check if you did it right. And then you can always look back, did you graph the correct y-intercept? Did you start at the right spot? Okay, so you can always kind of look back at these. You have to have an idea what you're doing. All right, a few more graphs. So we're going to step it up a notch here. We have y equals x squared plus 1. So this is a nonlinear graph. The ones we've been doing so far are just lines, which would be called linear graphs. Okay, now we're looking at nonlinear. So this one right here is what's called a quadratic, okay? And then this one right here is an absolute value graph. So we'll look at those, and then this one is called a rational function. So we'll look at these three quick, and we're gonna do all three of these with an XY chart. So you're gonna wanna get that ready for each one of these. So starting out, XY chart, we put an X here. We put what we're plugging our X into right in the middle, and then we put what we're going to get back out right over there. And we can stick to our generic values. Okay, so plugging it in. Remember, when you plug in or when you substitute values, you want to use parentheses. That will make quite a bit of difference here, okay? And I'll show you what it would look like all the way down, and then we'll get our numbers. All right, if you're using your calculator, which is okay, the parentheses make a huge difference, okay? Because remember, if we looked at this first one right here, if I did this versus this, you're going to get two different numbers out. Your calculator would give you a -4 here, your calculator would give you a +4 here. This is the one that you want to do. That's important for getting the correct graph, okay? Not this. Make sure you do it right in your calculator. All right, so up here with the first one, all right, so we have a -2 squared, which is a 4, minus 1, we get a 3. -1 squared, which is 1, minus 1, we get a 0. Then we have 0 minus 1, -1. 1 squared is a 1, minus 1, which is a 0. 2 squared, which is 4, minus 1, we get a 3. And you see this nice pattern over here. You got 3, 0, -1, 0, 3. That's what you want to see when you're working with quadratics. They're going to have a pattern like that. So let's graph our points. Remember, this is the x coordinate, this is the y coordinate for each of the points. So we go left 2, that's my -2, up 3, and then I draw a dot there. Then I go left 1, and I'm at 0, so I go left 1, up and down none, so I'm at 0. And then I go to 0 and -1. Then I'm going to go 1, 0, and then I'm going to go over 2, up 3. All right, and then we're going to connect the dots. So we're kind of going from here down to there, and then back up, and that's kind of what we have. So that's called a quadratic. This is a parabola. And the nice thing about these, I said they have that pattern. They are symmetric. Okay, so we should have the same thing on this side of the graph as we do over here. The points should be reflections of each other. Okay, I'm 2 units away there, I'm 2 units away there. I'm 1 unit away here, 1 unit away here. That's how you know you did that right. If they're symmetric on both sides, if you cut it in half, okay? So that is a parabola. They could be much more complicated than that, but the general way to attack these is use your XY chart, okay? Go from -2 to +2. If that doesn't tell you enough, you might need to go from -3 to +3, -4 to +4, okay, or other values, all right? This one, absolute value graph. Again, we're going to use an XY chart. So go ahead and see if you can kind of work ahead of me, making the XY chart on this one. So this is how we set it up. And then again, we're doing our -2 to +2. Okay, so plug those values in to your absolute value, see what you get. And this should be like a V shape when we're done, okay? This is V for value, so absolute value graphs look like a V. Okay, so you're going to plug every value into your absolute value brackets, and that's just going to take everything, turn it positive. So it's pretty straightforward after you're plugging stuff in. And then take your points, put them on your graph. -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, and then connect your dots. So we have our graph going like this. Okay, so this is your absolute value graph. We got the big V there. Okay, one more, and then we're looking at interpretation of a graph. All right, we're almost there. So this is called a rational function or reciprocal function. And these ones are pretty unique, okay? These ones are a little bit different because you're going to get undefined values on these ones. But again, we tackle it with XY chart. We don't know what it looks like, but we can figure it out by using an XY chart. And we can stick to our generic values. Okay, it's kind of nice that we can figure out anything with this XY chart. We're just doing 2 over x. So the first one will look like this. 2 over -2, you get -1. 2 over -1, we get -2. 2 over 0, uh-oh. What happens when you divide by 0? Can you divide by 0? No, this is undefined right here. Okay, you cannot do it. All right, so we got to keep rolling with some more points. So we have a 1, plug in the 1, 2 over 1, you get a 2. 2 over 2, we get, oops, we get a 1. All right, so really all we have right now, we got -2, -1, so we're here. -1, -2, we're here. And then 0 doesn't work, so we can't do anything with that. And then we got 1, 2, so we're here. And then 2, 1, we're here. Okay? I don't have any idea what that's supposed to look like yet. So if this happens, we're going to need more points. Luckily, this is not a very difficult graph to plug stuff into. So let's do more values. Let's say we're going to do -3, -4, +3, +4. All right, so we have 2 over a -3. That's a -2/3. And then we have 2 over -4. That's a -1/2. So those get smaller. All right, so we can do those ones. So -3, then you're like, well, how do I graph a -2/3? You're going to kind of eyeball it. If I imagine this little square chopped into thirds, 2/3 would be about right there. Okay, same thing with the half. So I go -4 and a half. Okay, so now you can kind of see that we have a curve kind of going on here. So let's do the same thing with the positives. 2 over 3, you get just 2/3. 2 over 4, you get 1/2. So you can kind of see the same thing happening over here. We got 3, 2/3, 4, 1/2. So we have that same kind of curve going on over here. All right. So when we run into these reciprocal functions, it might be necessary to plug in more points, but what happens here is it creates these invisible barriers, okay? They're called asymptotes. So these are lines that my graph will not cross. So it's pretty much the axes, okay? So asymptotes, this is how it's spelled. And those are going to kind of have a barrier for us. So this is what the graph looks like. I kind of have a parabola shape on both sides of my axis here. Okay? And that's what a reciprocal or a rational function looks like. So you may need more values to get a good idea what the graph looks like. Okay? So the last thing we want to look at here, we have some words here. We're going to try to put a graph into words or put some words into a graph. Okay? When John Waiters went to see his mother in Cincinnati, he boarded a Southwest Airlines plane. The plane sat on the runway for 20 minutes. Okay, this is going to be some good information. Plane sat on the runway for 20 minutes. And then the plane took off. The plane flew at about 600 miles per hour. Here's another one, 600 miles per hour for about 2 hours. So any kind of movement, this is like a distance time graph or a speed time graph, any type of movement of the object will result in movement of the graph. Okay? It then reduced its speed to about 300 miles per hour. Okay, and circled the airport for about 15 minutes. So 300 miles per hour, circled the airport for 15 minutes before it came in for a landing. Okay, so 15 minutes and then it's going to go to land. After landing, the plane taxied the gate and stopped. Which graph represents all these words? Okay, so looking at these three graphs, you've done them in physical science before. You've seen them before. You may have seen them in other science classes that have some physics in them. Okay? So my speed over here, that's how fast I'm going. That's the y-axis. My time is the x-axis. Okay? So we can do some elimination here. So we sit on the runway for 20 minutes. So we're sitting still for 20 minutes. So that means it's going to be kind of like this where we're flatlined for 20 minutes. Now this looks about the same as this, so we can't get rid of those. All right. Down here, I got another one where I'm just sitting still, not doing anything. Now this one looks like we got some movement going up. So this one we can eliminate because we have some movement right away from 0. Okay. Let's read the next piece of information. The plane flew for about 600 miles an hour for about 2 hours. So we're going to fly at 600 miles an hour for 2 hours. So that means if I'm looking at these graphs here again, I'm going to have to get up to 600 miles an hour right away. So I'm going from sitting still to 600 miles an hour pretty quickly, and then I'm flying at 600 miles an hour. So that should be kind of here for a little while for my 2 hours. So that means this one's out. Okay? So then we're kind of looking at this second one on the right and then the one down here. So let's take a look at this one. All right, so we go from sitting still up to 600 miles an hour. That's what we want to do. Let's compare the other one. All right, looks about the same. So we're going to have to kind of eyeball where this is. So let's say that we're at like the 40-minute mark here, okay? And that looks to be about the same for this other graph. And then let's see how long we stay at 600 miles an hour. So about to here before something happens, okay? So we're going from 40 to maybe 160. Is that that's about my 2 hours, right? So I got 120 minutes. That's my 2 hours before I start dropping down. Okay, so let's check out this one. So same kind of deal before I start dropping down. So those are about the same. We can't eliminate either one of those, all right? But we can look at these and kind of compare what the words are to finish. So this one right here, up here, I slow down, go to 400, slow back down, and then here it looks like I increase back to 100 miles an hour. So I'm slowing down to 400, slowing down to maybe 5, 10, but then I go back up to about 100. And I don't remember reading anything about accelerating back to 100 miles an hour. Okay, this one, we go to 400. I do see something here that says 300. So let's check our other one to see if we're down to about 300. And we are. So this is the one, okay? So you really have to kind of use process of elimination to understand which of these graphs is going to be your correct answer, okay? And you kind of saw we did have to use most of the pieces that we were given to eliminate the 3 and figure out which one it was, okay? So pay attention to your axes, pay attention to the labels on the side, and pay attention to where my flat spots are and what miles per hour they line up with. And that should help you through these, okay? So that concludes our graphing. So I hope we know now how to use an XY chart and we know how to graph different functions. We can graph linear functions and beyond. Here is your assignment. So please do this on graph paper. All right, it's going to help you keep everything square. You're not going to have to draw your own graphs. I don't want you to draw your own graphs. I want you to use graph paper, okay? So thank you for watching, everybody. Have a great day.